Okay, so wrapping up section 5-5, we're still solving polynomial equations. This time we're going to integrate quadratic form. So we'll go right into an example. So this will be example 5. So we're going to write 2x to the 6th minus x to the 3rd plus 9 in quadratic form if it's possible. Now, I've been stressing how important writing parentheses within your equation is, and you'll see why when we work through this example, the importance of that. So I'm just going to rewrite the equation. So I have, again, 2x to the 6th minus x to the 3rd plus 9. So we have to get it written in our quadratic form, which, if you'll remember, is ax squared plus bx plus c. To make that happen, we have to look at our 2x to the 6th and say, okay, what can we do to make it where my exponent, when I square it, takes me to the 6th power? So 2 being our leading coefficient won't be written inside the parentheses here. Instead, what we're going to have is 2 outside the parentheses, and then I'll have x cubed inside the parentheses squared. So technically my a is the 2, x cubed would be the x of the formula, and then it's squared. So I technically have ax squared written with a is 2, x is technically x cubed, and it's squared. Now, the next part is x cubed. Now, that we just have to write that where my leading coefficient is outside the parentheses again. So the leading coefficient for negative x cubed would be a negative 1. So I'm not going to write a number in right there. And the way I'll rewrite this one will be I'll have x cubed inside the parentheses because technically it's not raised to a higher power. So the x in the bx portion of the quadratic formula, the x will be just x cubed. Last part, plus c, is the easiest part. Just take the constant 9 and add it to your equation, and that's your answer. I technically have ax squared minus bx plus c. Another example would be, let's take x to the 4th minus 2x cubed minus 1. Now, this is an example that won't work. And the reason it won't work is because we cannot write this equation or this expression in quadratic form because x to the 4th cannot be rewritten to a term where it is squared. So x to the 3rd power squared will not work in this sense. So no, this cannot be rewritten in quadratic form. Okay, so example 6, we're going to kind of change it a little bit. We're going to solve equations in quadratic form. And this is what I was talking about, the difference between factoring and then solving equations by factoring. It's just slightly different. So this example, we're going to look at x to the 4th minus 29x squared plus 100 equals 0. Now this is an equation. This isn't an expression. It's an equation because we have something that is being solved for. So it's going to look similar to how we've been solving with quadratic functions. We're just going to have to slightly alter the way we write this. So first thing we should do is rewrite our original equation, and then here's what we do. Write it in quadratic form. So to rewrite this in quadratic form, my x to the 4th, being my a, will be x squared, and then I'll square that because x squared squared will give me x to the 4th, as you can see to the right side. For my bx, my b is negative 29, and then my x is technically x squared. So regardless, this equation is now written in quadratic form. And so we can denote that, like I said, the x squared being squared is technically the ax. So next step after that is, and this is where a lot of people may get confused, but don't freak out, we're going to substitute the letter u in for every time x squared is written in. So we have 2 places where x squared is written, in my a spot and my b spot. So I'm going to substitute that with u. Now for my a spot, I technically have x squared squared. So when I substitute my u in, my u is still squared. But now this green equation now looks much more like a quadratic equation, u squared minus u plus my c value. Just make sure that you remember when you substitute like this, and this is totally okay, and this is actually a help or a cheat if you want to call it that. You can take out these really large expressions, x squared, even if it's cubed and beyond, you can substitute letters in to make it simpler to solve. We'll just make sure towards the end of this problem that we substitute x squared back in for u. But for the time being, let's leave it like this. So, next thing, we're going to factor multiples of 100 that combined give me negative 29. So that would be negative 25, negative 4. And we just set it up like we're just factoring a quadratic expression. So u minus 25 times u minus 4 equals 0. The next thing we're going to do is we're going to use the ZPP, the zero product property. It's equal to 0, so set both sets of that equation equal to 0. So u minus 25 equals 0, u minus 4 equals 0. Once you apply the ZPP, you realize that your u value can be 25 or your u value could be 4. But remember, our u value is not what we're solving for because we substituted u in for x squared. So we're going to go back now and we're going to replace u with x squared. Now don't get this confused. If you feel like you can go through this equation using x squared in all of these places, by all means go for it. It's just a simpler way to see your equation set up. Either way, you will find yourself at the end at this same expression that's in blue. X squared equals 25 and x squared equals 4. Now, after we have that, this page is the exact same thing that we just had on our bottom 3 lines here, just on this line. So we've replaced u with x squared. Now, if you'll remember, if you'll think back to yesteryear, to your backwaters of Zimbabwe, all we need to do now is take the square root of both sides. So when we do that, remember, if we use the square root to cancel out a squared value, our answer is either going to be, or will be, plus or minus. So it now goes to x equals plus or minus the square root of 25 and x equals plus or minus the square root of 4, which we know by solving that, x equals plus or minus 5, x equals plus or minus 2. So the expression or the answer I'd like for you to give me is by simply stating the solutions of the equation are 5, negative 5, 2, and negative 2.